Hello everybody, it's Dumplet here, and here's an item on geometry. Let n be a positive integer less than 2021. It is given that if a regular octagon is rotated n degrees clockwise about its center, the resulting octagon coincides with the original octagon. How many possible values of n are there? As usual, pause this video if you would like to give this item a try. And if you're done, let us dive into the solution. Now, I'll be showing you guys this image. The blue figure is the octagon. The point in the center is the center. And then here is a vertex of the octagon and a line through the vertex and the center of the octagon for reference. Now, I'm going to spin the octagon a full 360 degrees about the center, and I want you guys to count how many times does the new octagon, the spinning octagon, coincide with the original octagon. Alright, so let's count it together. There are 1, 2, 3, 4, 5, 6, 7, and the 8th time it goes back to its original position. And we note that in one full 360 degree rotation, there are 8 occurrences from start to finish that the spinning octagon coincides with the original octagon. And the number 8 is very, very nice because it's an octagon, it's a polygon with 8 sides. In fact, if we go back to some of the moments where the two figures coincide, let's take the first occurrence. Note that in this occurrence, the octagon has spun 1/8 of a rotation. All right, so it's the angle between this line and that line, and we know that is 1/8 of the entire rotation. Now for the second case, it has spun 2/8 of an entire rotation, so 2/8 is also 1/4. So since 2/8 is equal to 1/4, so 1/4 of 360, we know the angle is going to become 90. Well, since it's a right angle, it's kind of obvious from the figure as well. So by logic, if on the third occurrence, we would expect that it has spun 3/8 of the way of an entire circle, of an entire 360 degrees. Now let's try to go back. Note how in one rotation it's 45 degrees, so we know that in the original given, if n was 45, then in a 45 degree rotation clockwise would result in a coinciding figure. In this, we knew it, what we saw from the figure, it was a right angle, and we said this was 90. And in the third figure, we said that it's 3/8 of 360. In fact, if you're going to get 3/8 of 360, you're going to get it's 135. So we can say that this angle is 135. Now let's just note 45, 90, and 135. In fact, they are multiples of 45. So by our patterns, the next few angles would also become multiples of 45. So we keep adding 45 to our previous answers. So in fact, we simply count the multiples of 45 up to the largest one, less than 2021, since we're given at the start that n is less than 2021. So like we have the first three, 45, 90, and 135 from our simulations. So we know that the next one we can actually get them by just adding 45. In fact, we can get the next are 180, you add 45, 225, 270, and so on. So if you want to get, since we will only want the number of multiples of 45 that is less than 2021, we can easily use the floor function. So the floor function just tells us the greatest integer that is smaller than this. So we simply divide 2021 by 45. Now if you actually do this, it's going to give you an answer of 44 and 41 over 45. So it's almost at 45, but it's not yet 45. So we just take the number, or we just take the integer that is, or the greatest integer that is less than this. So we have the answer of 44. And this will be our final answer. Hopefully you guys learned something new today, and I'll see you guys in my next video. Bye bye!